Solve the following system of linear equations over Z mod 5. So our approach here is going to be to use Cramer's rule. What does Cramer's rule say? If I have a square matrix A times a column vector X, where the entries are Xi, equal to another column vector B, what we're going to do is, to get each Xi, we're going to take the matrix, replace the ith column with B, and take the determinant. Then we're divide by the determinant of our original matrix, assuming the determinant's non-zero. So, what do we need to compute? We'll need to compute 4 items. The determinant of the matrix, which has entries coming in from the left-hand side, and then we're going to take that matrix, replace each column with our B vector, take those 3 determinants. For our first one, let's take a look. So here, we're taking the determinant of the matrix. That's going to be given by 3 by 3 matrix. So our rule is we put the matrix next to itself. I multiply down each diagonal going to the right, and then once I cross the line, I'm going to subtract off what I get when I multiply all the diagonals going down to the left. So when I do that, what happens? Since we're in Z mod 5, I want my final answer between 0 and 4, so it's going to wind up being equal to 2 when I crunch it down. We're going to need to know what happens when I divide by 2 though, so I have to find out what 2 inverse is in Z mod 5. That's going to be equal to 3. 2 times 3 is going to be equal to 6. Subtract the 5 off, that gives me a 1, and 1 is our identity, so that has to be the inverse. Okay, we're going to go after x1 now. So what am I going to do? I'm going to replace the first column in the matrix with our B vector, gives us this matrix here, and then same procedure for getting the determinant. We go down each diagonal, multiply down and add it up, and then when I get to the other side, I'm going to multiply down the diagonals going to the left and subtract them off. What do we get? For this determinant, I'm going to get a 3. So x1 is going to be equal to 3 over 2. The inverse of 2 is going to be equal to 3. So this is just 3 times 3, which is 9. Subtract the 5 off, and I get a 4 for x1. To get x2, we're going to take our B vector, put it in for the second column, take its determinant. So what do we get? We're going to get a minus 18. I add 20 to that. That's going to give me a 2. If I divide that by 2, we're going to have x2 equal to 1. Finally, to get x3, I put the B vector in the third column, take the determinant. What comes out? We get 30 minus 8. The 30 goes to 0, so I have minus 8. I add 10 to that, I get a 2. To get x3, I have to divide that by 2, so I get another 1. So our answer is going to be, x is going to be the vector 4, 1, 1. Finally, we take our solution, put it back into the original equations to check our answer, and we'll note that our answer checks out.